Hello, good morning from this side. So today we are going to learn about operations, casting and exception handling. So under the operations, we are going to learn about um, arithmetic operation, logical operation, and comparators. Okay, and under typecasting, simply typecasting is converting one data type into the other. Okay, so exception handling is also like handling exceptions when a code fails. So in case something goes wrong, what should the code do? Okay, or in case you are trying to process a particular data and it fails, what alternative should it happen instead of just throwing the error onto the screen with the red sign? But what's the alternative? So these are the three topics I'm going to take you through in this video, but it will be broken down into pieces. So first and foremost, we are going to focus on operations, especially arithmetic operation, logical operations, and comparators. So let me add here, we have what? Operations. So I'm going to start with operations. Okay. So from here, now under the operations category, we have arithmetic operation. Okay. So with the arithmetic operation, the basic arithmetic we all know from school is addition, subtraction, multiplication, division. Okay. So for the addition, you use the addition sign on your keyboard. For subtraction, we use the hyphen on the keyboard. Okay, there's nothing like a subtraction sign, so you use the hyphen on the keyboard. And for multiplication, we use asterisk. Okay, so you put an asterisk to do multiplication. We don't use an x. We don't use this. An x is a symbol x, but not a multiplication sign. So if you want Python to recognize your multiplication operations, you use what? An asterisk. Okay. Then when you come to the division, you use a slash. Okay. So 3/2, meaning 3 divided by 2. Okay. Now I'm going to explain this first for operations. Then later on I talk about this next two operations, just to avoid some confusions and make it more clearer. So in terms of addition, we have, you can say, let's say print 12 plus 4. Let's say 12 plus 5, and we have 12 plus 5. Let's run our code to see the output. So when we print 12 plus 5, it gives us 17, and it's correct. Okay, so that is our addition operation. Now let us look at our subtraction operation. Let me just say subtraction. So I say print, let's say 4 minus 70. Oh, sorry, hyphen 70, meaning 4 minus 70. Then let me comment this print out. I don't want us to see the output, so let me run it, and we get negative 66. So whatever be the case, you can make a subtraction and you get your answer. It could even be a float. Okay, 70.2, 4 minus 70.2, and it works fine. So whether it's an integer or it's a float, you can still do your addition and subtraction. Now let us take a look at multiplication. So we print let's say 3 times 4, and we're expecting the answer to be 12. Let me comment this solution out. Why is this thing disturbing me? sorry. So we print out only the multiplication sign, and we have 3x there is 4, giving us 12. Plus 3, 4 is 12. Okay. So then the last one we do our division, and let's print out print let's say 10 divided by 5. Okay. So let me comment this one out, and we get 2.0. So 10 divided by 5, you get 2.0. Now take a note in terms of the division operation. Anytime you divide, you get a float. Even if the answer is supposed to be an integer, or the answer can be an integer. Let's say 4 divided by 2. 4 divided by 2 is 2, and 2 as an integer is fine. But then anytime you perform a division operation, whether your answer is going to be an integer or a float, the computer presents it as a float. So in this case, we are seeing 2 as our answer, but it has what? 0.0, making it what? A float. So anytime you make division, the result you get out is a float, and you should be able to know that you are working with a float so that you understand some of the things, the do's and don'ts of floats. If you are working with integers, you can do that. So later on I'll show you the typecasting. Okay, so we are done with the first three the first four operations. Now let us take a look at the power. So power is simply exponents. Okay, power or exponent. So maybe you want to raise a number to a number. So exponent. So let's say you can say that print 2 raised to the power 3. So you use a double asterisk to signal that you are raising it to what? A power. So 2 raised to the power 3, and let's print it, and we get 8. So 2 is 4 times 2 again is 8. So that is the power. Now sometimes people want to use a square root. So I put in, let's say I put in 4. I want to find the square root of 4. Now square root means that the power is 0.5. Okay, means the power is 0.5. Cubic root means the power is 0.3333. All root symbols, anytime there's a root, it's simply a fraction. 1 over the number, whether if it's square it is 2, if it is cubic 1 over 3, if it is whatever it is 1 over that number. So square roots are basically fractions, like are basically raising a certain number to a fraction. Okay, and we'll stick to square root. So 4 asterisk asterisk 0.5, meaning the square root of 4, and we're expecting our answer to be what? 2. So 2 times itself will give us 4. Okay, and this is how you deal with your power. So let us look at the last operation, and sometimes it confuses people: floor division. So we have floor division. Now floor division is just like the normal division that we do, except that the computer will run the value down. The value will be run down. So should in case, let me say print let's say 10 divided by 3. Okay, let me show an example. 10 divided by 3. Now this value is going to give us this 3.33333. Forget about the 5, but just we are going to get this value 3.3333. Okay, a lot of 3's. Now if you tell the computer don't just do division but do floor division, that means you increase the number of division sign to 2. 10 divided by 2, the answer we are going to get is this, only 3. So, and the resulting answer is an integer. So let me show you an example. Let us look at a comparison example. So print 5 divided by 4. Okay, then we say print 5 floored by 4. Okay, so we have these two print functions. Let us see the difference in their answers. Now you realize that the first one, the answer given was 1.25, but with a floor division, it removes all the decimal numbers. It doesn't round it up, it removes all the decimal numbers. Let me show you another example. Divided by 1.5. Okay, so 5 divided by 1.5. Okay, so 5 divided by 1.5, we're expecting to get 2.1. No, we're expecting to get 3 point something. Yes, 3.5 something. Oh, 3.333. Yeah, let me see if I can get something that has a 0.5 decimal place. Okay, let me use 2. Okay, so 5 divided by 2 is 2.5, but then 5 floored by 2, automatically the computer removes the 0.5 and leaves you with 2. It doesn't round it up to 3. Okay, so floor division means floor, come down, remove everything, just come down to the nearest whole number. Okay, so that's, I think I've said enough on floor division. And the resulting answer is an integer. So anytime you floor something, you get what? An integer. Okay, so that's simple and straightforward. So I've covered the topic on operations, and the next video is going to be on logical operations, that is the AND, OR, and the NOT operations. There are more of the logical operations, but I'm going to focus on these three in our next video. Bye.